Here we go, third year in a row, it's time for the 2023 5-inch FPV Freestyle budget build. This year's drone is capable of 6S, has onboard Bluetooth so you can do all the setup and tuning right on your phone. This thing can very easily carry a full-size GoPro. We've got ELRS on board, and the best part, this drone is only going to cost you $200 in parts. Alright, let's look at the parts that I'm using for this year's build. Usually when I do these build videos, parts sell out pretty quick, so I'll leave some alternative parts next to the ones that I use in this video. Also, prices change. One day a part could be $20 and then the next day it'll be $23. In general though, the parts that I use in this drone should always total to somewhere around 200 bucks. For the frame this year, we're going to be using the latest and greatest, the Sourceone V5. Now you can get this from Get FPV, Race Day Quads, Pyro Drone. You can get it from a bunch of US retailers, and it's always going to cost about 30 bucks. Last year we used the V3 frame. The V5 frame has been out for long enough now where there's a good amount of 3D printable parts for it, so this is the one we're using. Speedybee F405 V3. I almost went with the V4, but I wanted to keep the build under 200 bucks for you guys, and that would have pushed it $10 over. I used this in my budget build last year, and in my opinion, it is still the best budget stack that you can get for the money. This thing sells for only 60 bucks, and it's easily the best bang for your buck. It's got Bluetooth built in, so we can set up the drone wirelessly using the Speedybee app. We've got 50 amp ESCs that are capable of 6S, plus it's got tons of pads to hook up pretty much anything you need. GPS, beeper, LEDs, all that good stuff. If you have an extra $10, definitely take a look at the new Speedybee V4 stack. I have a whole review video on that, and I'll leave a link to it right up here. Otherwise, I really think the V3 for the price is still the best that you can get. Next up, the motors. For this build, we're going to be using T-Motor's new Velox V3 2207 1750 kV motors. So this drone is going to be capable of 6S. T-Motor makes some awesome equipment. I used their motors in my recent long-range build, and the thing flies awesome. The V3s come in at less than $15 a piece, which is actually cheaper than the Eco 2 motors now. Next up, the camera and the VTX on this build are going to be analog. Analog gear is some of the cheapest that you can get. Plus, if you're new to the hobby and you're upgrading from an all-in-one kit, chances are you have a set of analog goggles, probably something like this. Those will work perfect with the equipment in this build. For the VTX, we've got a nice little Happymodel OVX303. This has 25 to 300 milliwatts output power, and this was selling on Race Day Quad's site for only 13 bucks. I like Happymodel products, so I was like, you know what? It's going in the budget build. The VTX comes with a pretty cheap antenna, but you can always replace it to get better range if you wanted. Camera-wise, we've got the Foxeer Razor Micro 1200 TVL camera. I don't have many analog quads at this point since I've upgraded most of them to DJI or Walksnail, but the few analog drones that I have actually have this camera on it. I was surprised to see that this thing was only selling for 19 bucks. Receiver, this is going to vary from build to build, but I'm using a Happymodel ELRS receiver. This is their EP1, and it's probably the cheapest ELRS receiver that you can get, 13 bucks, just like the VTX. For props this year, we're going to be using some of these Azure? How do you say it? Johnny Freestyle props. These are 5-inch Freestyle props. I've been using these on a couple of builds, and I love how these perform. Also, last but not least, this isn't required, but I would definitely recommend it. This is only an additional 3 bucks or so. Get some of this mesh wire protector. This is going to go around your motor wires, and it's going to prevent them from potentially getting chopped up in a crash, and it just keeps the build nice and clean. All right, so the first thing we got to do, put your frame together. I'm not going to show you how to do this because it's pretty straightforward, and the Sourceone V5 frame is a very widely used frame, and there's tons of documentation on how to put this thing together. All the parts you need are included in this little bag. You get the standoffs, screws, everything's included in here. So I'm going to put that together. You're going to need a little screwdriver. I'm going to be using this. This is an electric screwdriver kit. I got this for like 20 bucks. I'll leave a link to this down in the description, but it comes with every bit you'd ever need to assemble a drone, and yeah, that's what I'm going to be using. I'll leave a link to it down below. Otherwise, let's put our frame together. All right, time to mount the motors. Don't put your top plate on yet. This is going to be easier to do when we're at the end. I have the little camera plates on here. I'm going to have to remove those, but whatever, dude. Get it to this point. Make sure the screws are, you don't have to have them completely tightened down, but enough to hold it in place. Now it's time to put our motors on. So we'll grab our motors, get them out of the box, and we're going to mount those directly to the frame. So all of the necessary hardware that you will need to mount the motors comes with it. So you're going to get this bag of screws, you get the motor, and you also get a little propeller nut in there too. I'm just going to put that on now. I'm going to show you guys how to put one of these motors on, and you can do the remaining 3. So you get a bunch of different screws in the kit. These are different lengths, I think. So when we're putting this motor on here, it doesn't matter which arm it goes on. All the motors are going to be the exact same. Since they're brushless motors, they can spin clockwise or counterclockwise. When you're looking at the drone like this, we have the camera up here, so the drone is facing this way. We have motor 1, 2, 3, and 4. Unless you go into Betaflight and start remapping the motors and remapping which motor is what, that will always be the case. So I'm going to mainly focus on motor 1, showing you guys how to hook this up. So I'm going to take this motor. We have 2 different screws here. We have some smaller ones and then we have some bigger ones. We're going to be using the bigger ones on this. So these ones they give you 2 different sizes in case you're using a frame that's thinner. This is a pretty thick frame. This frame is going to be very durable. How thick are these arms? These arms are 6 millimeters thick, so these are pretty thick. So we're going to be using the bigger screws to fit all the way through the frame and then into the motor. Now when you're doing this, you shouldn't have any problem because this is the biggest screw that they include. But if you did end up using your own screws that are a little bit longer than these, just make sure that the screw doesn't go up into the motor, because if you have this screw go through that and into the motor itself, like into the winding, you're gonna ruin the motor, so don't do that. So now take out the other 3 motors and do exactly what we did to motor 1 on the rest of them. All right, so now that we've got our motors all hooked up, it's time to get our flight controller ESC stack on board. Underneath this cover, we have long screws for the flight controller, as well as more vibration dampeners. We've got a capacitor in here too. And then we have our wires to connect everything. And we also get an XT60. So it comes with everything you need. First thing we gotta do is we gotta get these long screws out of this bag. So when I was assembling the frame, I only put in the 20 by 20 mounting screws. Those are the 4 screws right here in the middle of the plate. The outer screws I left open because we're gonna be using these long ones to secure down our flight controller. So the screws that came with the frame are only this long, so don't use those. We're gonna use these. Now we're going to put these in the same way we did the other ones. And now just screw them all the way down. All right, so you get those 4 screws in, and those aren't only going to be holding the flight controller ESC stack, but it's going to be holding the arms in place as well. So we have 2 screws per arm that are just kind of holding those in. So if you did have to replace an arm, all you got to do is take out those 2 screws and then the arm should come off. So now the ESC and the flight controller can go on those 30 by 30 mounting points that we just installed. So this is going to sit in the drone right like that. We're not going to keep it on here because we have to solder up the capacitor and the XT60. So the way we're going to do this is it comes with the capacitor and the XT60. So I'm going to open this up. Looking at the capacitor, you have this mark on the side. That's for ground. So we're going to make sure that that is hooked up to ground. Now the way that I'm going to hook up the capacitor right now is I'm going to take the ESC off, and if you look at the battery pads on the ESC, there's 2 little holes. Those are meant for the capacitor. So what you can do is you can actually feed the capacitor through those holes, and it just makes soldering 10 times easier. So we're going to do that, and I'm actually going to mount it from underneath right like this, because what I'm planning on doing is I'm going to have the capacitor bend like that to sit back a little bit. If you do this in the drone, it makes it a little bit easier when you go to solder it. So I got my soldering iron heating up, but this is how we're going to be connecting the capacitor. I have it being fed through those little holes on the bottom of the ESC, and I kind of positioned it right against the frame, and that's going to just keep it nice and clean. So we have the positive and negative poles kind of sticking up, so I'm actually going to cut those a little bit above the where they come through. So those are still coming through. Make sure it's all pushed down correctly. That's exactly how I want it. So I'm gonna take some flux. And if you guys don't know how to solder, I'm not gonna go over how to solder in this video. I have a whole other video on soldering if you're curious about it. I'm not the best solderer, but you know what? It does the job, whatever, dude, I don't fucking care. I'm just gonna heat this up, feed some solder on there just to secure down the capacitor. And then we'll move on to the battery lead. That looks good. just enough to hold the capacitor on there. Now it's not going to fall out. It's in there pretty good. I'm going to be using some of this blue tack. This is meant for hanging stuff on the wall, but you can use it to hold circuit boards and stuff too while you solder to it. So I just push it down onto my table and then push the ESC lightly onto it. And now that isn't moving anywhere, and it just makes it a lot easier to solder to it. So now it's time to get the XT60 on here. Again, keep in mind, voltage is red, ground is black. So this is going to be flipped over like that. I'm going to tin these ends right here just to make it easier to connect. There's probably a little solder on there already, but it really does help having it on there before you put it on. And I'm also going to tin the battery pads, so I'm going to put a little bit more solder on there. Just a little bit, you don't need too much. So now taking our XT60 battery lead, we'll start with the negative because that's on this side. We've got some solder on the end here, and we've got some solder on the pad just to make things easy. There's ground. And you can kind of push it into the pad. That'll kind of just help heat everything up. There you go, that'll work. All right, so now this is pretty much ready to go on the drone. The only thing I'm gonna do before I put it onto those screws and leave it, I'm gonna take this ribbon cable right here. This came with the flight controller stack. This is gonna connect the flight controller to the ESC, and it's gonna plug into this port right here. This is the only plug on this ESC that you have. Plugs in only one way. Make sure that is plugged in all the way. There you go. So now this is going to plug into our flight controller, and we can secure this down on the frame. So this is going to sit right like this. Lift those up a little bit, and these will get fed right in between there. All right, so the next thing we're going to do is we're going to get our motors hooked up. Now before we start soldering, I'm going to take some of this mesh wire protector, and again, this isn't needed, but you should secure the motor wires down somehow. This stuff just makes it very clean, and you can get this whole roll for like, I don't know, $3. This is gonna be going around the motor wires, so I'm gonna measure out how much I want. I'm gonna have about that much. Just kind of eyeball it. Doesn't have to be crazy exact. What really helps with this shielding is if you take a lighter and just kind of lightly melt the outside so it doesn't start fraying. You don't have to hold it for too long, just enough so that it starts to kind of melt together, and you should be good. So now what we can do is we can take our motor wires and we're gonna feed it through this wire mesh. Perfect. Slide that all the way up to the motor. That looks pretty good. And a couple of these small zip ties. I'm gonna run this through here. And this is just gonna hold it in place, and I'm probably gonna keep this on after we're done anyways. So put that on, cut the excess off. So now that's kind of holding it nice in place and just out of the way. I'm actually gonna do this with all of these motors just because having these flop around while I'm trying to do this, kind of distracting. So I'm gonna do that real quick and then we'll continue with motor one. All right, so the way I'm gonna be running my motors, you can do this any way you want. You can have it go straight to these three pads. These three pads right here are motor one. These three pads right here are motor two. And then these three are motor three. And those three, motor four. So you can run these wires any way you want. You can run them straight to those three pads. The way I'm gonna be doing it though, because we do have a lot of space in between the flight controller and the ESC, I'm actually gonna run these wires towards the power connector, and then they're gonna turn and they're gonna go like this straight to the pads. So when you're doing this, make sure that you have enough room between the grommet on the ESC and the grommet on the flight controller so that you are able to make sure that it's sitting nice and flat. But these wires are eventually gonna be running right like that. So it's gonna keep it nice and clean. Again, you can run these however you want, but that's how I'm gonna do it just to keep this looking good. So the first thing we gotta do is put a little bit of flux on these motor pads, and then we're gonna tin them, and then we're gonna trim our motor wires so that they can go onto those pads easy. Nice. So with the motor pads all tinned up, it's time to hook up our motor. So like I said, I'm gonna be running the motor wires along this way, and it's gonna go right like that. So right where my thumb is, that's where we're gonna be cutting the wires. This is a good way to measure it. So now let's just splice the ends. You can use wire strippers if you want. I just use my thumbnail. Whatever, dude. So let's tin those wires. Now run them as they're supposed to be ran, right like that. So I'm gonna start with this first one. This one's going right like that. So we'll solder this one down first. 1. 2. 3. So now motor 1 is hooked up. We can obviously clean this up a little bit just to make sure that those wires are sitting nice and flush. That looks awesome. So I'm gonna do that exact same process for motors 2, 3, and 4, and then our motors are all gonna be hooked up. Look at that. I've honestly never soldered wires like this before on an ESC. This is my first time doing it, and I love how this came out. This keeps it nice and clean. You don't have any wires hanging off the side here. I've seen a couple of drone builds where people do this, and I've wanted to do one for some time, and I think this is the perfect build to do it on because the ESC is kind of sticking out a little bit on this frame. When you take the flight controller and put it on top, you'll actually see that there's still a lot of room between those wires and the flight controller. So, love how this looks. Next thing on the list is going to be putting our flight controller on. So the flight controller is going to have a little arrow. There's one right down bottom here. No matter what flight controller you get, you're probably going to have that arrow, and that is always pointing forward. You can configure the flight controller to sit right, sit left, sit backwards, sit sideways, sit upside down. It's easiest if you can just mount it like this. So we're going to mount it like this. This ribbon cable right here that's connected to the ESC, we can connect that into this port right here. This one's meant for a DJI Air unit, and this plug isn't even going to fit in that one. It only fits in this one, so it should plug right in, right like that. Make sure that it's pushed in all the way. And then this can sit right on the 30 by 30 mounting. So now we're going to take these that were included with the flight controller, and we're just going to secure that down because we are pretty much all set with that. All the rest of the soldering that we're going to be doing is just to this top board. So now let's hop over to the camera, VTX, and receiver. Those are the only 3 components that we're going to have to solder to the flight controller. So let's start with the camera. This again comes with everything you need. So this is going to control the image on the camera if you need it to. Here's a nice long cable for the camera. And then this is going to hook into the back of the camera in case you need to adjust any settings. You really shouldn't have to adjust them too much, but they include this in case you do. And here's our camera. This camera is going to fit right in the frame, right up front like that. And then this is going to plug right into the back. We have a little pin out. We've got video, ground, and VCC, or voltage. So we're going to make sure that this plugs in the right way. It only plugs in one way. Take these little screws out, and we're going to secure the camera down, and they include a bunch of washers in case you need them. Otherwise we're just going to need these tiny little screws, and the camera is going to sit pretty much in these plates. So we're going to pull these plates out, and the camera has text on it so you can tell which way is right side up and which way would be upside down. Don't install your camera upside down. Take these brackets, you can choose which hole you want to put it in. So screw that into the camera through the side plate. Make sure you have it in the exact same hole, otherwise it's not gonna sit on the frame correctly. And there's your camera. So now we can slide this back where it's supposed to go. You've got 2 grooves in the bottom of the frame, and this should just click right into place, right like that. And now we have a bunch of excess wire from the camera, so I'm actually going to trim it about here, and we'll save this. Put a little bit of flux on all of these pads up top. All right, so real quick, I want to show you guys the pins that we're going to be soldering to for the camera, receiver, and video transmitter. First off, the camera right up front. These are the wires for the camera. We're going to be hooking those 3 wires up to the 5-volt ground and cam pins, these top 3 right here. Over on this side, we have 4 more pins that we're going to be using for the receiver. We've got ground, 4V5, R2 and T2, so UR2 is going to be used for the receiver. 4V5 is basically going to power the receiver when we hook up a USB connection to this, so you can power the receiver without having to plug a battery in, which is nice. So that's what the receiver is going to be hooked up to. And then for the video transmitter, unfortunately, that requires a 5-volt input, so we won't be able to use the plug-and-play port down the bottom that's meant for an air unit or an O3 air unit. So instead, we're going to use this 5-volt pad right here. Right next to that is a ground, and then underneath we have UART1, we have R1 and T1. We're mainly just going to be using the TX or T1 pad for smart audio, and then right next to that we have VTX, so that's where the video transmitter wire is going to hook up to. So mainly these 4 pads down the bottom. So I'm going to put a little bit of flux. We'll put some solder on there just to get it ready so we can solder everything up. Let's start with hooking up the camera, since that's right here and ready to go. I'm going to actually unplug it because it's going to make this a little bit easier. We'll take these wires, trim off the ends, just kind of exposing the wire, right like that. Let's tin them. We'll start with 5 volts since that's closest to me. We'll get ground, and then cam right next to it. So this is going to be the video image going out of the camera and into the flight controller, and then it's going to be pushed out the VTX tab and into our video transmitter. And this plugs in right like that. Boom, there's your camera. Let's do the same for the receiver and then the video transmitter. Is there no wires in this? Are you kidding me, Happymodel? All right, so Happymodel didn't include any wires with the EP1 receiver, so what we're gonna have to do is we're gonna take some of the wires from the flight controller stack. It's pretty much the same cable that's connecting the flight controller to the ESC, just a little bit longer. So what I'm gonna do is I'm actually gonna cut the ends off, and we're gonna use this to hook up our receiver. So we'll take the white, red, black, and we'll use the yellow, and these are going to be our receiver wires. So we'll trim the ends down, tin them up, and we'll get them soldered to the receiver, and then we'll get it soldered to the flight controller. Tin those pads a little bit. Boom. Boom. So we'll start with ground, since that's on the far end, closest to me. Voltage right next to it. Yellow on the next pad, and that's going to be the TX pad. And then we'll use white for RX on the far end. So now when we're hooking up the receiver to the flight controller, something to keep in mind is you want to reverse how you connect the TX and RX pads. So on the receiver, I have the yellow wire hooked up to TX and the white wire hooked up to RX. So the white wire on the flight controller is actually going to hook up to TX, and the yellow one is going to hook up to RX. So you want to reverse them. Picture it this way. You have a transmitted signal that's coming out TX, and you need something to receive that signal, so you're going to hook it up to RX. So what this is transmitting, you're going to want the flight controller to receive. So transmit, receive, it kind of makes sense when you think of it that way. But yeah, TX to RX, RX to TX, and then ground to ground, voltage to voltage. So let's hook that up to these 4 pads right now. We'll start with ground, since that's the closest one to me. do voltage next to the 4V5 pad right next to the ground. And then remember, TX is the yellow wire that I have on mine, so that's going to connect to RX. So that's going to go to the next pad. And then this white wire is going to go to TX because that's hooked up to RX on the receiver. Sick. There's your receiver. So now you can take this and kind of coil it up just to keep these wires nice and tidy. And what we're going to do is we're going to take the heat shrink, I'm going to put it around here, and I'm going to slide it down the wires because we have to hook up our antenna. And then our antenna is going to go underneath this. I'm actually going to trim the zip tie off and we're going to put a new one on just to make this a little easier. And we're going to run the antenna underneath, and it's going to go up, and we'll just secure this to about that location. Just somewhere on the arm is fine. All right, so I got the antenna secured down just using a couple zip ties, and then we have the wire going underneath this one, and this is the zip tie that's just holding the motor wires down. So now we can take that and we can hook it up to our receiver, and then we can tuck the receiver out of the way, kind of up near the video transmitter. I'm actually going to take this heat shrink off, and we're going to have it sitting like this. So I'll hook up the antenna so that it's kind of in the same direction as the wires, and we'll take the heat shrink, put it around it like that, and this is just gonna kind of live up here next to the camera. Tucked underneath the camera, very nice. All right, so now it is time to hook up our video transmitter. So this is the video transmitter, and they didn't include wires with this either. So what we're gonna do is we're gonna take the other plug that we got, and this is meant for an air unit. Now, if you're using an air unit, obviously you can just plug it in and you can attach this end to the air unit and you're good to go. Since we're not using that, we're gonna actually cut up this wire and we're gonna use this one to hook up our VTX. So I'm gonna do the same thing that I did with the receiver. I'm going to just cut this end off. Same with this end. Now we're left with wires for our video transmitter. So I'm going to use the black one, we'll do the red one, and we'll do the yellow and white, same as the receiver. All right, now do the same thing to these. Splice these ends off, tin them up, and then we'll get them attached to the video transmitter. We got our 5-volt up top, ground underneath that. Underneath that, we have our smart audio, and then on the very bottom, we have our video tab. So I'm gonna have these wires run over the board because it's gonna be sitting in the drone kind of like this, and the flight controller is gonna be up here, so the wires are gonna go up that way. Take the red one, we'll start with voltage. Ground, and now we'll do white for smart audio, and then we'll do yellow for the video. Those pads are really tiny. If you're not good at soldering, I would definitely suggest getting a practice board and just practice on some really small pads, but those are pretty small. I forgot to show this, but attaching the antenna, pretty straightforward. You have the little UFL connector right here, and if you wanted to upgrade the antenna from something like this, you're not gonna get the best range out of something like this. I'm gonna use it just in this video, but if you wanted to upgrade this, all you would need is a UFL to SMA adapter, and then you could use any SMA antenna with this build. So I'm gonna use this one. All you do, put it on there, click it down. You'll feel when it clicks down, and you're good. So we've already got these pads tinned, so let's just grab the bottom two. So we'll do video first. The yellow wire is gonna connect to VTX. Now I'll grab smart audio, and that is what's gonna connect to the TX pad. You wanna make sure that this is on TX, not RX, otherwise it won't work. do ground first, right here. There you go. Now we have our video transmitter all hooked up. So as far as mounting the VTX goes, you have a couple different options of how you could do this. You could get some heat shrink and just kind of zip tie it to the frame. Don't just zip tie the board itself right like this to the frame, because then I'm sure you'll short circuit something. The carbon frame is conductive, so it can short out equipment. So don't do that. At the very least, put it in some heat shrink. The way that I'm doing this is I'm actually using some of the spare camera screws, and then I have these little M2 nylon standoffs. I'll leave a link to these down in the description. You can get these pretty cheap. I'm using these. These are gonna sit on the 20 by 20 mounting holes on the back, and basically with the VTX you have these additional ears on the side. So I'm going to remove the 25 by 25 holes, so the outer two holes. I'm gonna just remove those, and you can just cut them off right like that. And now the video transmitter is gonna sit perfectly on these little standoffs that I got. So I just fed it through the XT60 a little bit. And now this can sit on the standoffs. Right like that. And then we can use a couple nylon nuts to just kind of hold it down. So now let's get the top plate on here. The top plate fits on pretty easily. You have grooves up top for the camera. So this is just gonna sit in right like that. Boom. Get a bunch of leftover screws from the frame. So we'll put those in. And the nice thing about this frame is there are a lot of 3D printable parts available for it. You don't need the 3D printed parts. And if you don't have a 3D printer, there's race day quads. If you send them an STL, like say if you wanted a GoPro mount for this, you could probably honestly just buy a GoPro mount for this frame from race day quads. Or if you have a specific mount or a specific 3D printable item that you want on this drone, if you send them the STL, they'll actually print it for you, and they charge pretty fair for it. So if you do need something 3D printed, check out Race Day Quads. I'll leave a link to that service down below too. But yeah, there are tons of 3D printable parts for this frame. Pretty clean. You got a lot of space above the flight controller, so you can put a strap there to hold your battery on. Oh yeah, speaking of the battery, we also got this battery grip. So let's take this off and put this on real quick. This thing is nice. I love how this came out. So the only thing that's really left is tuning in Betaflight, and we'll take it out for a flight. Before we do any of that though, we gotta plug this thing in and make sure it starts up. So when you're doing this, I would highly recommend getting a smoke stopper like I'm about to use. This is a smoke stopper. You can get these on Race Day Quads, Get FPV, Pyro Drone. They pretty much all sell them. But what this does is when you plug in a battery, if you were to just plug in a battery right now, if you had a short somewhere on the board, if you had two pads that were bridged, you could destroy the flight controller, and then it's not repairable. If you have something like this, it's gonna actually detect the short and stop battery voltage from going into the flight controller and potentially ruining your equipment. So let me go get a battery real quick and I'll show you how this works. So here I have a Tattoo 1050. When I plug it in here, we're gonna see a red light, meaning that it's getting power from the battery. And when I plug this into the drone, if the light stays on, the drone's gonna start up, and we know that everything's good with the drone. If the light turns off and you don't hear any startup sounds, that means that you have a short somewhere on the board, and you're gonna wanna go back and just double check your soldering. So let's plug this in and see what happens. You can see the video transmitter's on, the receiver's flashing up front. We got lights on the flight controller. Love it. All right, so now that we know that this thing starts up fine and all the soldering is on point, let's go plug this into the computer and start tuning it. All right, so it's time to tune the drone. When you're doing this, make sure you don't have any props on the drone. We're gonna be plugging in a battery. So I'm gonna plug this into my computer, and we're gonna start with ESC configurator. So we are gonna plug a battery into this right off the bat. So I'm gonna open up Chrome, and you go to ESCconfigurator.com. Make sure you're not running Betaflight in the background, because if Betaflight connects to the flight controller before ESC Configurator does, you're not going to be able to connect to it through this. So make sure you don't have Betaflight running in the background. We're going to go to Connect. We can plug our battery into the drone. This is going to supply power to the ESCs. Now we're going to hop down to Read Settings. It's going to read the 4 ESCs. It should read it as BLHeli-S. So we see we have BLHeli-S on every single ESC. So what we're going to do is hop down to Flash All ESCs. And this is going to just write BlueJ to them. So we'll select the firmware, BlueJ. Keep this at whatever pops up. It should be GH50 if you're using this board, but typically you don't have to change this at all. Go down to version and we'll select the latest one, which is 19.2. PWM frequency, set that to 24, and we'll hit Flash. So now we'll just let this do its thing. It's going to flash the firmware to every ESC, and then we'll continue. All right, so once that's all set, it'll go back to this screen. Now you shouldn't have to adjust anything on this side. The only thing that I really adjust is the beep strength, and this is pretty much the volume of the startup tune. And I usually adjust this to about 20 or so. We'll do 19. And once you've adjusted whatever you want to adjust on this side, like I said, you really shouldn't have to adjust anything. Just click Write Settings. It's a lot faster than when you're flashing firmware, and now it's done. So let's disconnect from this and we'll open up Betaflight. So once we open up Betaflight, let's hop over to Update Firmware. We're going to select Auto Detect. This is going to automatically detect what flight controller you have in the drone. You should see Speedybee 405 V3. That's the board we're using. 4.4.2 is the latest version. I'm running 4.4.2 already on this flight controller, but I'm going to show you guys how to flash it anyways. Turn this off, full chip erase, have that on. And then this stuff down here looks pretty good. You shouldn't have to adjust any of that. Just make sure that this says Speedybee 405 and you're flashing the latest firmware, full chip erase, and we'll load firmware. Looks good. We'll hit Flash Firmware. It's going to give you this wipeout settings. We haven't done anything on this flight controller. This isn't going to affect the ESC firmware. This is just looking at the flight controller. So we're going to hit Ignore the Risk. So now just let it do its thing. It'll flash the firmware and then we'll continue. All right, so now it's all set. We'll hit Connect. You're going to get this Apply Custom Defaults. We're going to apply custom defaults. Now you'll probably be greeted with this warning. There's no motor output protocol selected, so we'll do these two things first. The accelerometer we can actually do from this initial screen. Make sure the drone is on a stable level surface. We'll hit Calibrate Accelerometer. So that's going to eliminate one of those warnings that popped up. And then we'll go down to the Motors tab, and ESC Motor Protocol, we're going to be running DShot 600. And since we just flashed BlueJ to the ESCs, we're going to turn on the ESC sensor and bidirectional DShot. That looks good. We're going to come back to this Motors tab in a little bit when we're adjusting the direction of the motors. So we'll save reboot. All right, so now let's hop down to the Ports tab. Now, the receiver we put on UART2, so that's good. We're gonna keep that just how it is, serial RX. You want that enabled on whatever UART you put it on. If you put it on UART3, turn it off here, turn it on here. We're using UART2, so just keep this the same. This one we're gonna keep on because this is actually the Bluetooth that's built into the flight controller, so we're gonna keep that on. And then we have the ESC sensor on UART5. So those are kind of the default settings. The only one that we have to turn on that isn't on right now is our video transmitter. So we want to turn on smart audio for that. So we used UART1 for the video transmitter. So we're going to go all the way down to peripherals, and we're going to select the drop down and then turn on smart audio for the VTX, right like that. And that's the only one that we really have to adjust. Save reboot. Now we'll go down to configuration. I usually adjust the arming angle to 180. Make sure you have air mode on. If you have any LEDs that you hooked up to it, turn that on here. And then DShot beacon configuration. So since we're running DShot, we can use the ESC beeps as a beeper. We're going to turn this on and this on. So when you have the beeper function enabled on your controller, when you click that, it'll beep the ESCs if you don't have a designated beeper. So that's all we have to adjust in here. So we'll save and reboot. Let's hop down to, we don't have to do anything in power, battery, failsafe, presets, PID tuning. You actually don't have to do any tuning on this. You can if you want to, but I think the drone flies pretty good without any tune. And I feel like tuning is kind of its own beast. There's tons of videos on tuning a drone, so if you wanted to get into that, you can, but for this build, you don't have to. So PID profile settings, we're gonna keep the same. Rate profile, this is kind of stick response and how the drone flies. Again, we don't really have to adjust anything in here, and we don't have to adjust anything under filters either. All right, so now what we're gonna do is hop down to the receiver tab. So I have my controller right here. I have a, what is this thing? ELRS module that I have on the back of my Mambo is the Beta FPV Super G 1 watt module, and it's not bound to my receiver yet. So let's go into our Wi-Fi settings and just kind of look at the available networks, and you should see Express LRS RX. We're gonna connect to this, and if it asks for a password, the password is just Express LRS. Once you connect to that, it should open up a web browser, and you'll be able to configure all the settings for your receiver right through here. So this receiver is already running 3.3.0. Binding phrase, key in your binding phrase, whatever you have on your controller, use that as the binding phrase and it'll just automatically connect. So I'm gonna go through here, I'm gonna key in my binding phrase. And then we'll hit save. Upload succeeded. We'll hit reboot. And on your radio, you should then get reception. So now our controller is bound up to the ELRS receiver. Let's go back into Betaflight, and you should see stick movement now. So if it looks like this, all you have to do for this is go down to the channel map right here, and we're gonna change that from default to spectrum, and you can also put it on FR Sky if you're still having issues. But if you change it to this, when you hit save, should be all set. Double check, make sure throttle's throttle. My throttle's only going to that percentage because I have this knob mapped to throttle control. So we'll have it maxed out for this video, but make sure that all of those are responding correctly. Make sure your buttons are popping up, and that's good. So now we'll hit save. Now that we have the controller all set up, let's hop over to modes. And this is where we're gonna set up all of our switches and what modes we wanna turn on with those switches. So make sure you have hide unused modes turned off. We're gonna go to arm. So this is gonna be arming the drone. Make sure this says auto. And all you gotta do is flick the switch that you want to be the arm switch. I use this one to arm the drone, so I'm gonna click this. You'll see that little yellow dot right here move when I click the switch. So I want it to be armed when the switch is clicked down. So we'll move this so that the yellow line goes within this bracket. So now we're gonna do this with all of these other modes. The other ones that I like to turn on, I like having angle just as an emergency kind of thing. So I'm gonna put that on this switch, and this is a 3-position switch. So you can see that yellow dot has 3 different positions. So I'm gonna use this downward position for angle mode. Now we'll go over to beeper. Definitely want a beeper. Click this. So that's gonna be our beeper switch. Adjust that. And let's do flip over after crash. At range, I'm gonna use this one. So that will be flip over after crash. So now I'll hide unused modes. Let's save. And now let's just kind of flick through the switches and make sure that everything is adjusting how you want. Looks good. All right, so now that we're set with the modes tab, let's hop down to the motors. So when we're doing stuff with the motors, we're gonna need a battery plugged in. When you're doing stuff on the motors tab, when you're doing anything in Betaflight and you have to plug a battery in, take your props off. I have had drones spin up, spool up, and if I had props on, I don't know what would have happened. So make sure you have props off when you're doing this. We're gonna plug a battery in. Go down here and just make sure that motor 1 is motor 1, motor 2 is motor 2, and so on. So by clicking this little box, we're gonna get these sliders to light up, and now we can move each motor individually. So motor 1, that's good. Motor 1 spins, motor 2, motor 3, and motor 4. Cool. So since we're in this tab, we can actually hit the master, and that's gonna spin up every single motor. And what you can do once you have these on is lightly touch each motor just kind of on the side, and you can kind of feel which way the motor is spinning. So motor 1 on this is actually spinning counterclockwise, and it should be spinning clockwise. Motor 2 is spinning clockwise, clockwise, counterclockwise. So since that's the case, what we can do is actually just check this box and we're good. Hopping back down to the motors tab, if you did have to change the direction of a single motor, say this one was spinning counterclockwise and the rest of them were spinning clockwise, you could go into motor direction, I understand the risks, and then use the wizard to kind of spin up each motor, and you can click for it to change direction. We don't have to do that. We can just select motor directions reversed and we're good. Let's unplug the battery because we don't need that plugged in. I'm gonna go down to the video transmitter tab. Now this is actually very straightforward. We're gonna minimize this, and on our web browser, we're gonna go to Happymodel's site, and they have this all laid out for us. It's literally just a copy and paste from their site. So copy and paste your choice of protocol VTX table into Betaflight CLI. So they have an IRC tramp protocol. We selected smart audio, so we're gonna use the smart audio one. But if you used IRC tramp, you would use this VTX table. We're using smart audio, so we're gonna select this one. So starting at save, copy this entire thing. We'll go back into Betaflight. We're gonna go down to CLI, and we're just gonna paste everything from their site right into here. And now when we open up the video transmitter tab, we should see all of these channels preloaded as well as the power levels. So pretty much ready to go. All you would do is select your band, channel, and power, whatever your goggles are on, and you should be good. I typically use race band 3, and we'll do power 25, and that should be good. To make sure that this works, I'm going to plug a battery in. And as you can see, I don't have any video on there, but as soon as I change this to race band channel 325, the video transmitter is gonna start putting out the signal that is on my goggles. So I'm gonna hit save, and now we have video. So we're all set in here. We'll hop over to OSD. You could have done this before. I usually do it after I have the video transmitter set up. But this is pretty much just where you're gonna set up the text and stats that you see in your goggles. I'm not really gonna go over this with you guys just because it's pretty straightforward. You just select what you want. Usually I like to have battery, cell voltage, alerts. If you have a GPS, you can do that. All of these things, you can kind of go through and select the ones that you like. And then once you're up here, you can just click and drag, and you can move this one over here. You can move this on the very bottom. You can have your goggles on while you're doing this, and you'll be able to see the image of where they're actually sitting on your screen. So just kind of play with it, select the ones you want, and once you're done, hit save. All right, we're ready to take this thing out for a flight test. The battery that I have on board here is a Tattoo 1050 6S LiPo. I'm also gonna be printing a GoPro mount for the front here, so I'm also gonna have a GoPro Hero 11 Mini up front. So you guys will be seeing footage from the GoPro, as well as some footage from this camera, which is basically what I'm seeing in the goggles while I'm flying. So let's take this outside, see how it flies. There you go, guys. Another freestyle budget build in the books. This thing flies awesome without any major tuning. You can always go back and play with the PIDs and rates if you want. I mainly wanted this to be a drone that didn't require much Betaflight tuning, since I know a lot of people use these budget build videos when they're just getting into the hobby. Regardless, I'm happy with how the drone flies on this current setup, but you could always play with the tune if you wanted to eliminate some of that prop wash or any wobbles or anything. The Speedybee flight controller on this thing, in my opinion, is still the best you can get for the price. If you have an extra $10, definitely check out their new V4 flight controller. It's very similar, but it has a couple upgraded features. Otherwise, it has the exact same pad layout as the V3. We used the V3 on last year's budget build, but we really didn't take full advantage of that V3 stack since it was a 4S build. With these new T-Motor 2207s, we're really able to take full advantage of that stack and have some fun on 6S. I feel like I always get asked if you can upgrade to use DJI on a build like this, and the answer is yes. The only thing you would need to do is, instead of buying the VTX and camera that I used in this video, go get a RunCam link with a camera like the Wasp or maybe a Polar Vista unit and install that stuff in place of what I used, and you'll have a DJI ready drone. I'll include links down in the description to digital equipment that would work on this build. Dry weight of the drone, you're looking at 355 grams. When you add a GoPro Hero 11 Mini, you're looking at 489 grams. And then when you add a battery like this 1050 6S LiPo, you're looking at 670 grams. So if any of these parts sell out, I'll have alternative links, so you should be able to get this stuff on a number of different sites if one doesn't have it in stock. The last thing I have to cover, every year I get asked if I can custom build people drones. I wish I could, but just straight up, I do not have the time to do that. I make videos like this so that you can learn how a drone like this goes together, and when you inevitably crash, you'll be able to repair it yourself. I think a big part of FPV is crashing and just learning how to build these drones yourself. So that's it for this year's budget build, guys. If you enjoyed this video, make sure you subscribe to the channel for more FPV content and future build videos. Leave this video a like, and if you have any questions about my 2023 Freestyle FPV budget build, leave a comment down below.